This is a schematic of a basic residential forced air furnace. Power comes in from a circuit on the left. As long as the system switch is closed, current will flow through the normally closed low limit switch to the transformer. If you're like me, you open this switch in the summer so as not to waste power keeping the transformer warm all summer. I also shut the pilot off in the warm weather to save a little propane. Take note that the drawing is arranged electrically with no real thought as to the physical location of the components. For example, the low limit switch, the aux limit switch, and the fan switch are all located in the plenum, but the drawing might not suggest that. Everything is showed in the power off state. The system switch is manual operated mechanical switch like a light switch. This thermostat is a mercury switch that rides on a bimetallic coil. You can manually set the angle of this coil by moving the lever toward a cooler or warmer setting. The mercury in the tube falls to one side, which either opens or closes the circuit. The blower motor is a common electric motor, 110 volts AC. The limit switches and the fan switch are operated by probes that are in the plenum. When the probes heat up, the switches are either driven open or closed. The transformer just steps the voltage down for the thermostat circuit, reducing arcing at the switch and providing a level of safety for the homeowner. Let's walk through a simple cycle. So first, the system switch must be in the on position and the pilot light lit. If the temperature at the thermostat cools enough to close the switch, then current flows to the gas valve. Inside the gas valve, a coil is wrapped around a bimetallic strip. As the strip heats up, the valve opens and gas flows to the burner. Since the pilot light is lit, the gas ignites and the burner begins to heat the plenum. As the plenum heats up, the fan switch closes and the blower comes on. As the blower forces hot air out through the ductwork, the return air cools the plenum. If the plenum gets cool enough, the fan switch opens and the blower stops, allowing the plenum to heat up again. If the blower motor has failed, then a plenum quickly heats up beyond the fan cut-in temperature. When it reaches the low limit switch setting, the low limit switch opens and cuts off power to the transformer. If the thermal protection on the blower motor has opened or the blower motor has just failed, then if you listen carefully, you'll hear the burner cycling on and off on the low limit switch, and the blower never comes on. In this situation, some hot air may migrate through the ducts by convection, but more than likely, the house will not be comfortable. If the plenum gets too hot and the low limit switch fails to open, then the temperature of the plenum will reach the aux limit switch pretty quickly, and the thermostat circuit will open, which allows the gas valve to close and prevents a fire. Normally, the blower cycles on the fan switch and the burner cycles on the thermostat. When the living space reaches this thermostat setting, the thermostat opens, which causes the gas valve to close, which shuts down the burner. Eventually the plenum cools, which opens the fan switch and shuts off the blower. The system then sits in standby until the thermostat cools down again, starting the cycle over from the start. Note that if you have no power, you have no heat. Power is required to open the gas valve or to run the fan. In the event of a power failure, you can shut off all your breakers except the furnace breaker and one 220 volt appliance like an electric range or a clothes dryer. Plug a small generator into that outlet and you can run the furnace to keep your house from freezing.